Okay, so in this video, we're going to finish the notes for 8.2, which has to do with circuit diagrams and series and parallel circuits. Okay, so before we do that, I want you to access the periodic slide, which I will give you a link for now. And I want you to open up that slide, and I want you to answer this do now question. Okay, and so the do now question says, using your note, draw a circuit diagram that has a cell, a switch, and a resistor in that order. Okay, and so in your notes, you should have the different diagrams for a cell, a switch, and a resistor. And I want you to draw the circuit diagram that has those three things in it. And do that on the periodic slide, which I gave you the link for. Okay, so go ahead and do that now. Okay, so your circuit diagram should look kind of sort of like this. Okay, so a cell, remember a cell is basically like a battery, and the way you draw that is you draw two parallel lines, one long and one short. Okay, the longer line is the positive side of the battery, and the short line is the negative side. Okay, and so from there, you can draw the rest of the circuit. The way you draw a switch is usually you draw a switch kind of like this. Okay, you draw the switch open so everyone can see that it's a switch, and then you just keep drawing. And a resistor is kind of like a little squiggly line like this. Okay, so this is kind of what your circuit diagram should look like. Okay, so hopefully what you put into periodic looks something like that. Okay, so pause it there if you need to look at it some more. Okay, so today we're going to be talking about different types of circuits. We're going to be talking about series circuits, and we're going to be talking about parallel circuits. Make sure as you go through this video that you have your notes for 8.2 out, and make sure that you're filling in the blanks for your notes in 8.2. If you can't see everything in the video, you can also open up the notes presentation that's posted in Canvas. Okay, so there's two basic types of circuits. Okay, you have series circuits and you have parallel circuits. And you can kind of see on the slide kind of the difference between series and parallel. On the left here, you see kind of what the actual circuits might look like. And on the right side, you see what the circuit diagrams might look like. Okay, and so if you notice the difference between series and parallel, a series circuit is a circuit which only has one pathway for the current to take. And so, for example, usually the current is going to come out of the positive side of the battery. And if you follow along the current in the circuit, you see the current can only travel in one direction. Okay, because there's only one path for the current to take. Okay, and so that's like the key characteristic of a series circuit. There's one pathway for the current to take. Whereas in a parallel circuit, okay, so the current comes out of the positive side of the battery, and you see right here the current can split. Some of the current can go this way, some of the current can go that way. Okay, and then right here, what's going to happen is the two currents are going to combine and meet back up. Okay, and then they're going to keep going around, and then it's going to go back into the battery. And so in a parallel circuit, you actually have more than one pathway. You can have multiple pathways for the current to take. Okay, and it's the same thing in the circuit diagrams here. You can see the parallel circuit, the current is going to come out of the positive side. And then right here, okay, it can split because there's two directions that the current can go. It can go this way, or it can go this way. Okay, and then it's going to recombine right here, and then it's going to go back into the negative side of the battery. Okay, and so you can see, again, series circuit has one pathway for the current to take. Parallel, it's more than one pathway. Okay, so pause there before I go to the next slide. Okay, and so in the notes, you can see the key characteristics of a series and parallel circuit. In a series circuit, okay, everything is in a row, and there's only one pathway for the current to take. Now, what that means is that, for example, if you look at the simulation, or if you look at the animation here, if you have three light bulbs in series, if one of them goes out, all of the lights are going to go out. because there's only that one pathway for the current to take, if something goes wrong with this light bulb, or if you take this light bulb out, that means the current is going to stop completely, and it can't keep going because that pathway is cut off. Whereas in a parallel circuit, there's multiple pathways for the current to take, and so that means if one of the light bulbs goes out, that means the others stay on, okay, which is maybe a good thing. Okay, so pause it through, make sure you fill that into your notes. Okay, so let's do some simple examples in Pear Deck. Okay, so what type of circuit is this? Actually, we're not going to do this question in Pear Deck. You're going to answer this question in an Edpuzzle. What type of circuit is this, series or parallel? Okay, so this is definitely a series circuit. You can see that because the current that comes out here, it only has one pathway it can take. There's no places that the current can split. There's no like branches or anything like that. Okay, so one pathway, this is definitely going to be a series circuit. All right, so next example in your notes. Okay, what type of circuit is this, series or parallel? Okay, so this is going to be a parallel circuit. And the reason it's parallel is because the current's going to come out, and then right here, it can split into two different paths. Okay, and so because there's more than one pathway for the current to take, you know that it is a parallel circuit. Okay, so pause there if you need to write that down. And then finally, what type of circuit is this? Okay, so this is also going to be a series circuit because again, there's only one pathway here, like the other ones that we saw before. Okay, so now that you know the difference between series and parallel circuits, we can talk a little bit more about those. Okay, so fill in any blanks that you have here in your notes. And so series and parallel circuits or combinations of those can be found basically all over the place. Now, series circuits have an advantage in that they are easy to do. Okay, they're cheaper to make because they use less wiring. And anytime you have a circuit with a fuse in it, that's probably a series circuit. Okay, now parallel circuits are seen a lot more often. For example, in Christmas lights, if you imagine you go to the store, you buy Christmas lights to put on your tree or to put like on your house, usually those are in parallel. And so what that means is if one of the tiny little light bulbs goes out, all of the other lights still work. Okay, now sometimes when you buy Christmas lights, if one of the light bulbs goes out, sometimes like a whole strand might go out. That's because sometimes Christmas lights have a combination of series and parallel circuits. Okay, the other most common example of where you see parallel circuits is your house wiring. Okay, so if you imagine the circuit in your house, like when you plug something into the wall, you use like a plug or use like an outlet or something. Those are usually a parallel circuit. Okay, so for example, if I plug in a toaster into the kitchen, right, and let's say I turn the light in the bedroom off, the toaster is still going to work because there's multiple pathways for electricity to flow in my house. Okay, it wouldn't make sense to have everything on a series circuit because then you turn off the light in the kitchen and everything in the house turns off, and that would be that wouldn't make any sense. Okay, so parallel circuits are a lot more common than series circuits. All right, so the last thing we're going to talk about in this set of notes for 8.2 is how to find what's called total resistance. And so the reason we have to have total resistance is because we have the equation V equals IR, and this is what's called Ohm's law. Okay, and we talked about Ohm's law before, and we did problems with Ohm's law before. Okay, this is the main equation in this unit. Voltage equals current times resistance. Now the issue is when you have a series circuit or when you have a parallel circuit, the question is which resistance do I use? Because now usually I have more than one resistance because I could have multiple components in the circuit. Okay, so now we have to talk about what's called total resistance. Okay, and just to make it easy for us, we're only going to do total resistance for series circuits because for parallel circuits, the equation is more complicated. Okay, so we're mainly going to focus on this total resistance for series circuits. Now, for total resistance, we're going to write that a couple different ways. Sometimes you can see that as RT or R total, or sometimes you will see REQ for equivalent resistance. Those all mean the same thing. Okay, so everything we're about to talk about could be written as in those different forms. I'm going to write R total, but just in case you ever see a question on a test that says one of these other symbols, they all mean total resistance. All right, so let's take a look at how to do total resistance calculations. It's very simple. Okay, so to find the total resistance in a series circuit, what we're going to do is we're just going to take all of the resistances and we're just going to add them together. Okay, and so when you're connected in series, the total resistance is equal to R1 plus R2 plus R3 plus dot dot dot. Now, basically what that means is R1, R2, R3, those are the resistances in your circuit. Okay, usually those are going to be given to you in the circuit diagram. And the plus dot 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 basically just means you would keep adding however many that you have. Okay, so if I had 10 resistances and I wanted to find the total, I would just add up 10 different numbers. Okay, so adding resistors in series is very easy. All you have to do is add the resistances. Okay, so let's do some simple problems. Okay, so for example, and by the way, the total resistance is always going to be bigger than any individual resistance. And the reason for that is because if you're adding numbers, obviously the more numbers you add, the bigger the answer is going to be. Okay, and so the total is going to be bigger than any one resistance. All right, so take a look at example 1.5. Okay, example 1.5 says find the total resistance in the circuit shown to the right. Okay, so this is going to be a series circuit. And so to find the total resistance, remember total resistance, you're just going to add the resistances. Now make sure you look at the units because this right here is not resistance. 110V, that is the voltage. Okay, so remember resistance is measured in ohms, and the unit for resistance is that horseshoe-looking thing. That's a Greek letter omega. Okay, and so the resistance here, the total resistance is going to be 10 plus, okay, the second resistance, which is 15, plus the third resistance, which is 30. Okay, so I add my resistances. 10 plus 15 is 25, and 25 plus 30 is going to be 55 ohms. And so the total resistance is going to be 55 ohms, for example, 1.5. Okay, so pause that there and make sure you add that into your notes. Okay. Next question says example 2.5, calculate the total resistance here. Okay, so I want you to do example 2.5 on your own. Calculate the total resistance for the circuit. Okay, so again, we have a series circuit, and the total resistance for a series circuit, you're just going to add up the resistances because it's R1 plus R2 plus R3 plus dot dot dot. Okay, and so we have the voltage down here that has nothing to do with it. Okay, and then we have 1, 2, 3 resistances to add. 15 plus 10 plus 6. And if you add that up, you get 31 ohms. Okay, so remember the unit for resistance is ohms. Okay, so the total resistance is going to be 31 ohms. That's the answer to example 2.5. Okay, so pause it there and make sure you add that into your notes. Okay, and I believe this is the last example. And again, I want you to try to do example 4 on your own. I want you to calculate the total resistance for the circuit. Okay, so once again, we have a series circuit. We have the voltage is 120 volts. And then we have 1, 2, 3 resistors. And so to find the total resistance, I'm just going to add up the resistances. So I have 15 ohms plus 5 ohms plus 20 ohms, and that's going to be 45 ohms. And so hopefully that's what you got for example 4 in your notes. Okay, so please pause there and make sure you add that into your notes. And this is going to take us to the end of the notes for 8.2. Okay, if you're missing any notes at this point, please go back to the beginning of this presentation and go through and get any notes that you're missing. If you don't have the paper version of the notes, go to the IPC bin at the front of the room and look for the notes that say 8.1 and 8.2. Okay, you should be able to find both of those in there. As always, please let me know if you have any questions. As soon as you finish this video and you finish filling in your notes, please go to Canvas and complete the quizzes that is in Canvas. Good luck, and I'll see you next week.